So, good evening, thanks for having me. My name is Torgen Hauschild. I'm a co-founder and tech lead at Aipark. We are a deep tech startup in the mobility scene, and we solved a problem related to parking and curbside management. And my agenda today is to give you some insights what role plays which role plays AI in our technology stack, and what problem it can solve in mobility. So we are founded as a university spin-off in 2017, and we are growing since then to a multinational tech-driven team of 18 people right now with 8 nationalities. Our office is here in Library, which has become the center of mobility-based startups in Berlin. So we are directly around the corner. And what we are solving is the last pain point in car driving, which is finding a parking spot. With every drive today, drivers waste about 10 minutes only for parking. In Germany alone, this relates to 500 million hours wasted each year. And about a third of the traffic in cities is based on people searching for a parking spot, which is massive. Different studies have shown that there is enough physical parking space, but drivers don't know where they are. So what is missing is the information. And we solved this problem by providing maps that shows detailed information about parking. All of you knows the color coding from traffic in modern navigation systems. So red means there's a traffic jam, green means you can drive freely. And we adapt this concept to parking. So as you can see, green areas means there is a high chance to find a free parking spot at the right time. And red means all spots are occupied. And on top of that, we add a real-time layer, so we can show you when someone has parked hours close by. And we can do this because we have a crowd of about 40 million connected cars right now, where we get about 2.5 million parking events each day. So it's a massive data. And we organize this data in different layers. I hope you hear me. Good. So we use different AI technologies in each of these layers to implement them. In our rules layers, we use static data from cities, such as pricing, opening hours, and restriction. And to map on-street and off-street parking areas, we also use computer vision to analyze satellite images and on-street images to figure out where it is possible to park, and enhance our rules layers also by providing availability predictions. And for this, we also train neural networks for the regression part, where we use data from mobile phones and connected cars to GPS tracks to make a prediction where the parking pressure is higher and lower. And we have built a whole platform for this specific parking use case, which we called our parking platform. And via our easy-to-integrate API, we deliver this information to different customers. So our data can be integrated in connected cars. For instance, we have a project with bigger OEMs, and also app developers can integrate the data into build up mobility apps for different platforms. So to be sure that our system works, we have analyzed user behavior at the last mile for about 20,000 trips here in Berlin, and we have proven that with the Aipark, users find a parking spot 3 times faster, which, if you keep in mind that a third of the traffic is based on searching for a parking spot, is a huge impact. So, if you have a normal car navigation system, it navigates you to the destination, and then you are up to yourself to find a parking spot. We replace the last part of the trip with our parking assistant, and directly to a route where you have a high chance to find a free parking spot, or we direct you to a car park if the pressure is too high. So right now, there are a lot of trends which make the curbside even more crowded in the future. So in addition to parking, which was the use case until now for the curbside, new mobility providers come in place, and for instance, ride-hailing companies or delivery fleets use the curbside to pick up passengers or to drop off passengers, or doing the same for goods. So also micro-mobility services, for instance, Tier Mobility, which are around the corner, use the curbside for their vehicles, such as e-scooters, and therefore the curbside gets more under pressure. And therefore we built a platform which processes on-street images and collect information about the curbside state from dash cams and mobile phones. And we call this the mobile vision platform. With this platform, it is possible to get a live curbside availability information with the highest possible accuracy, as you can see here in the slide, in a big scale. So we use dash cams and mobile phones, which are mounted on dashboards, and process the corresponding images directly on the devices. This is known as computer vision on the edge, which is one of our core technologies. And the devices can detect and measure sizes of open parking spots up to 60 kilometers an hour, which is quite fast. It also works under difficult weather conditions and also different lighting conditions. So, because it's AI Monday, I will now dive into the technologies behind the mobile vision platforms a little bit deeper. And first of all, the devices themselves need to recognize and localize cars, and they need to the device needs to decide if it's a parked car or a driving car, which is quite difficult. And the data then need to be mapped directly to the curbside, so we need a georeference of the data. So how it works on the edge. We use a crowd of devices in the field, and which send out all the data which they recognize visually. And benefiting from our existing platform, we enrich this data by the existing parking information we have in our backend to build a holistic system. And everything is then accessible via our standard API to all our customers. So the corresponding architecture behind the technology on the edge is inspired by autonomous driving. First of all, you have the image from the mobile phone, which need to be processed to detect cars and traffic signs, and then these objects need to be tracked between different frames, and this needs to be done in real time on the device, which is quite challenging, and it must be robust against different, as I said, weather conditions and also adjustments of the camera. So in parallel, these objects need to be localized and need to be mapped to our curbside space. So these are different tasks which need to be run in parallel on the devices. So in autonomous driving, you have a lot of computing power for this purpose in the cars, but because we are using existing hardware in the field, we need to be able to run these neural networks also on mobile devices, as all of you have in your pockets. So because of this, we need to develop very performant neural networks, and the advantage is that modern smartphones have specialized hardware for neural networks, and we use this hardware acceleration to be capable to run all of this in parallel on the devices. So if you have more questions on this, you can come to me later and we can talk about it. And one aspect which also need to be kept in mind is the speed of the development. So as a startup, we need to develop software quite fast. We need to be ahead of the market, and therefore it's quite important to use existing data sets instead of developing everything from scratch. And therefore, one aspect is quite important, which is called domain adaptation. And domain adaptation means you use one data set which exists, train your neural networks on it, and later adapt this neural network to your specific domain. So to make it more clear, it is so strong, this approach, that you can train your neural network based on data from a computer game like GTA 5. And later on, you can adapt this neural network to also work in the real world, which is quite impressive. So you can imagine in a computer game, it's quite easy to say, oh, this is a car, this is a human, this is 10 meters away, this is 1 meter away, and therefore you can produce label data quite cheap and train your network with it. But later on you need to adapt this network that it generalized, that it also works in the real world. So this is one of our fields where we also do a lot of research. So another challenge is the localization of the objects. So again, in autonomous vehicles, you have a variety of specific hardware for this localization task. Most of the time it's LiDAR or radar systems, but on the mobile phone we just have the image. So we also use neural networks again, which can make a depth estimation based on single images, on monochromatic images, so which you can see here on the slides. So we can combine all the different neural network architectures to one system and be able to do the same as an autonomous driving car, but on a mobile phone. So as you can see, we have a lot of technical challenges, but the right solutions in place to solve them. Another very important aspect of the mobile vision platform is the operational part. So to realize a high update frequency of the curbside information, we partner together with different fleets, for instance taxis or deliveries. And so our system does not produce more traffic in cities, but reduce the amount of traffic in cities instead. Our platform provides information which are important for different use cases in the mobility sector. Starting with the automotive, it's quite obvious to start with the automotive and car sharing use cases, because there the parking use case has a high value, especially if you rent a car and pay per minute. You would like to find a parking spot fast, obviously. But on the other hand, also ride-hailing companies are interested in curbside information where they can pick up or drop off passengers safely. So as you can imagine, here in Berlin it's not a problem right now, but in San Francisco it's super expensive to park in the second row to leave also passengers as an Uber driver, because the traffic stacks, because so many Ubers are everywhere. So this is quite a big challenge for them. And here also our system can offer a solution. To make this system more available, it needs to be scaled to different cities, of course. And because everything is based on AI technologies and big data, we can scale our system quite fast. So we start this year in Berlin and San Francisco, because these are the main cities for us right now. But then we will scale until 2021 to all the metropoles in Europe and the US as well. So as you can see, we have ambitious goals, and therefore we extend our team. So if you like to work with the newest technologies in AI and with a great team, I would be happy if you reach out later on. So that's for now, and I'm happy to hear your questions.